Roger, go for deploy.
Alrighty, gang, welcome back to Adventure Fit Radio. Here is part 2 of the Geraint Lewis show.
Geraint.
Now, this is on Skype. We just did this. Again, super mind-blowing stuff. I actually fucking love this guy. I want to give him a hug.
Yeah.
I want to give him a really nice hug.
I want him to be my uncle.
Exactly right.
I'm going to ask him if he can be my uncle.
Yeah, Geraint Kerr.
I'll just change my name.
Just change your name
I'll
to
be
Geraint.
Kerr Lewis.
Or Geraint Kerr.
Or I'll be Geraint. I'll be Geraint Bill Kerr.
Geraint. Nah, he's an absolute champion, and he's so, you can tell in the passion of his voice, like you heard from the last episode, that he's just, he really truly loves what he does, which is amazing. We spoke a lot today. We actually spoke a little bit about aliens, which was cool. We spoke a lot about some of the stuff, some of the physics involved with Interstellar, and the very interesting topic of discussion of comets hitting the Earth and matter hitting the Earth.
Space safety,
which is actually really important because we are not that safe.
It's really scary.
We're not that safe at all right now. Guys, we are sponsored by Audible.com. They're a great little audiobook thing you can jump on when you don't feel like reading a book. Just get it all through, get all the content, the information through.
They're an audiobook thing, are they?
They're an audiobook thing, yeah. Obviously, I don't want to be too professional here. So if you jump on to audibletrial.com/ADVF radio, you can sign up and you can get one free credit. So you can get a first book free, basically. I just had a look at my wish list. I have basically the most, losery information. So I've got Elon Musk. I've got
Elon Musk.
Yep, I've got Origins by Neil deGrasse Tyson.
What is it?
Origins. I think I said Oranges there.
Origins he said Oranges.
Oranges. So Neil deGrasse Tyson, the famous astrophysicist, wrote a book about fruit, and that's Origins. Geraint Lewis, guys, you'll find out, actually is writing one called A Fortunate Universe coming out later this year. Hopefully that's going to be on Audible that we can all download.
What else you got on there?
Wanting to read The Iceman by Anthony Bruno, and then some Graham Hancock.
The Iceman by Philip Carlo or Casso is probably my favourite book.
Oh, really?
That's a different version of The Iceman that's on there.
Okay.
The Iceman from Philip Carlo is as good of a book as I've ever read.
Is it the original of this one?
No, it's a Richard Kuklinski story. I've seen that one.
Yeah.
It's
okay, cool.
Richard, The Iceman, for anyone that is interested, is about a hitman who had probably, I think they had 250, 300 more murders over a 45-year period. He had a loving family, 2 beautiful children, a respected member of the community, and he was just a brutal murderer for all the 5 families in New York. And it tells a story about him. So get on Audible and you'll hear it all.
Yeah, and I also want to read The God Delusion by Richard Dawkins. So, guys, jump on Audible. Awesome. We are also sponsored by Bill. Who are we also sponsored by?
Adventure Fit Travel.
Adventure Fit Travel. Now, isn't Mount Everest coming up?
By the time this show is released, there'll be a couple of weeks left to book in.
Okay.
So, if you want to come over to Everest with us, guys, get in quick. Time is running out. It'll be an awesome trip again. We're also going to the Philippines in November, and we have Kokoda coming up on Anzac Day, which will be April next year as well. And by the time this is released, there'll actually be another couple of sneaky trips that'll be up and running, but I'm not going to say them because sometimes I don't get things done on the time frame that I plan to do them.
Schnickety. Alrighty, guys, without further ado, here is part 2 of Geraint Lewis.
So, Geraint, let's take a little bit more of a different route from the Big Bang and from how the universe was created. I would like to hear your thoughts on space safety. So, what I mean by that is, why is the government not spending more money trying to look at the risks associated with us getting hit by an asteroid, some little fragment out of the Oort cloud? Like, why? Can you elaborate on your thoughts on that?
Well, firstly, we know that there's a lot of stuff out there which is potentially dangerous for the Earth. There's plenty of asteroids, and we're hit every day by rocks of varying size, but we know that there are some rocks which are very large, and we have comets that come in from the Oort cloud at regular periods. I think the reason that it's not high on the radar is that big collisions are quite infrequent. There was something that happened in the early 1900s. There was a giant explosion over Russia called the Tunguska Event.
Yep.
If that happened over a major city today, it would be absolutely devastating. But because these things occur once every century or few centuries, then it doesn't stay on the radar. But the big problem is that when they do occur, if we are hit by something big, then the results are pretty disastrous. And of course, the dinosaurs
found out the hard way.
Rocks either, and look what happened to them.
Yeah, that's true. So, how much has technology improved since the Tunguska event? I mean, surely we'd be able to foresee this sort of stuff.
Well, Chelyabinsk, we couldn't.
Hey?
Chelyabinsk, the most recent one, where the asteroid came through the atmosphere and then nobody even knew about it.
So why is that, Geraint?
Okay, so there's a couple of reasons. So technology has advanced a huge amount. We now have lots of telescopes around the world, and we have telescopes which are basically robotic, and they can survey the sky and they basically look for anything that moves. So we do have some of these programs which are ongoing. It's just that they haven't been going long enough to detect all of the stuff which is potentially dangerous. The most dangerous ones, though, are the ones that come straight towards us because they don't move on the sky. So if you've got a robotic telescope looking for things that move and something is heading straight for you and so it just remains as a dot, you don't know about it until the last minute.
Wow.
So,
that's scary. Scary to think about.
But the scarier thing is that even if we find something, there is nothing we can do about it.
Oh.
Really?
We have no technology set up to basically prevent any rock heading towards us from hitting us.
So we can't just call Bruce Willis and get the team, get him back out there? Armageddon 2? Is that realistically not an option?
It is not an option. The only spacecraft that we have that carry people into space at the moment, both the Russians and the Chinese have very similar rockets. They can get up to low Earth orbit, up to essentially where the space station is. We have rockets that can get out into into the deeper parts of the solar system. But what are you going to put on them? We don't have any technology that can stop an asteroid, deflect an asteroid, or destroy an asteroid.
So that sucks.
So basically we need to, if we were to ever find an asteroid that's coming directly towards us that we can't really see, we would have weeks or months to build the most powerful rocket you've ever seen with a nuclear bomb gun on it.
But part of the problem is, look, we love nuclear weapons, of course, they're very powerful, but it takes an awful lot of energy to deflect a rock, the size of a big asteroid. It could be, kilometers across.
Yeah.
And a nuclear weapon, the best you could probably do is crack a big object like that.
Really?
Jeez.
Even if you break it into pieces,
it's still coming for us, isn't it?
Coming for you. So instead of being hit by a big bullet, you're hit by a shotgun blast, which still dumps all that energy into the atmosphere and into the Earth.
Yeah.
It is one of the big issues that humankind has to deal with. Is we know these rocks hit, as you said, over Russia. There was the event only a couple of years ago. That was a relatively small rock. When the big guys hit, it can be quite disastrous. I said even the Tunguska event, that was the size of a very large nuclear weapon exploding, but luckily it was over a very empty part of Russia. So
Tunguska is a city leveler, basically.
Yes, absolutely.
All right. So what would in your mind? So say we get hit by something that's bigger than a city leveler, something that's going to cover half of North America, because doesn't that mean that all of the telecommunications is going to be set down, all the lights going to be left, and in all the cities around the world, we're only set up to really survive for, is it 3 or 4 days before food has to come in, and then why it begs the question why more isn't being done about it. More money is being spent on.
Well, so let's just go back to the impact. It's not only the place where it hits is going to be the issue, right? Because anything that is big enough is going to throw lots of material up into the atmosphere, and you're basically going to end up with the equivalent of what's called a nuclear winter. It was one of the worries about after a nuclear war. You throw up so much smoke and debris in the atmosphere, you block out sunlight.
Yeah.
And the temperature on the surface of the Earth will then plummet. A big enough event is going to do something like that, so we'd have to worry about that.
So would that be say the next size that's above Tunguska that hits North America? Would that have the potential to say it's like a 5-time bigger event than Tunguska? Would that have the potential to put so much cloud into the air to cause another ice age over North America?
I'm not sure about the exact size. It probably would be bigger. Have to be bigger than 5 times, maybe 100 times bigger. That has the possibility of bringing in, I said, one of these nuclear winter kind of effects. Now they don't last as long as an ice age because all that eventually gets rained out of the atmosphere and the sun comes out again.
Right.
But think about how long humankind, how many years we would last if we didn't have any crops each year.
Exactly.
For sure.
Which really, really sucks because it just goes to show how much we do rely on the modern way of living, especially when we didn't always need to do that. Hey, Geraint, I wanted to ask you slightly different tangent about this sort of stuff, just in relation to how good it is that we have Jupiter's gravitational pull in reference to all of these meteors coming in and how much that sort of saves these potential cataclysmic events. Can you shed some light to the listeners on what Jupiter does?
Right, so Jupiter, of course, is the biggest planet in the solar system, and it's much larger than the Earth. You could fit hundreds of Earths inside Jupiter. And so because it's much larger, it's got a very strong gravitational pull. And so having that planet in the solar system means that it looks like a big target to all these rocks. So rocks which are moving around through the solar system feel Jupiter's pull, and many of them have been pulled into Jupiter and have crashed into Jupiter rather than the Earth. So having Jupiter in the solar system has proved to be some sort of almost a vacuum cleaner for cleaning up a lot of the debris that would be potentially dangerous for the Earth. And it's still doing it today. It was only back in 1990 that comet Schumacher-Levy 9 flew past Jupiter. It got ripped apart, and then it went around the sun and then crashed into Jupiter itself. Wow. So that was another comet that had been removed from the solar system due to Jupiter's strong pull.
Wow. So the speed at which a meteor or whatever must be traveling to get through Jupiter's pull must be ridiculous for it to be any real threat to Earth. Is that what you're saying?
Yeah, so it's a couple of things. It's going to be the speed and the direction that these things are coming in from, because Jupiter sits, and all the planets orbit together basically in a flat plane. So the direction that things come in has an effect as well. But all these rocks out there, they're already moving at around 20 to 30 kilometers per second. So that's the typical speed of things in the solar system, which is why these rocks, when they hit the Earth, are so dangerous. They're carrying so much kinetic energy, which was due to their immense motion, that they basically cross from space to the surface in a fraction of a second, more or less, right? And they deposit a huge amount of energy. So these things are already moving fast.
So what about just in relation to the Oort cloud? So where does the Oort cloud sit? Because that's not a meteor that's coming from outer space that's got to get through Jupiter and its gravitational pull. That's basically in our orbit, right? It's a group of. Can you explain the Oort cloud to me basically and our listeners?
Yeah. So the Oort cloud actually isn't in our orbit.
Right.
So the Oort cloud is in the very distant parts of the solar system.
Gotcha.
So it's like the edge of the solar system. Okay. And out there are basically the leftovers from when the planets formed. So the sun formed from a cloud of gas, and in that gas, bits stuck together and eventually formed the planets. And those bits that didn't end up in planets are still out there in the very outer regions of the solar system. And what happens is that there's billions of them out there of all sizes, from size of a snowball up to hundreds of kilometers across. And if another star passes by the sun, and it doesn't have to be very close, it basically shakes the Oort cloud slightly. Mm-hmm. And then these leftover bits of forming planets, they fall into the solar system. So they stop orbiting way out, and then they fall in towards the sun. And these give us these comets that come from very deep space. And they're the dangerous ones because if you have a comet in the inner solar system, you can watch it orbit and go round and round and round, so you know where it's going to be and when it's going to be there.
Yep.
But if a comet has fallen from the Oort cloud, you just don't know when it's going to arrive because it's never been into the inner solar system.
Right.
So we have comets that appear and they fly past the sun and then they disappear again and we never see them again. So they've come in from the Oort cloud and then they've basically left the solar system. So they're the dangerous ones as well.
Right.
God.
Okay.
Alrighty. Hey, let's move on. Let's get straight into wormholes. Now, my understanding, G-Man, is that wormholes are a perfect mix of a black hole and a white hole. Can you shed some light on what a wormhole is and if it exists? I don't even know too much about this.
Okay. So we have to go back 100 years, back to Einstein working on gravity. So he basically gave us our modern vision of gravity, which is called general relativity.
Yes.
And in that picture, space and time are kind of rubbery. Okay, so if you bend space-time, that's how you create gravity, is by having a bend in space and time. And one of the ideas that people realize is that if you bend space and time enough, that you can actually connect one piece of space to another piece of space through a tunnel. And that tunnel is known as a wormhole.
Okay.
And there are different kinds of wormholes. There's the one that you sort of described there, which is a connection of a black hole and a white hole, i.e. you fall into one and you pop out the other. But there are other structures people have thought about where you basically think of it more of a tunnel that you can travel in both directions. So we have the mathematics for describing a wormhole, but we don't know if any wormholes actually exist in the universe.
Right.
So they're a theoretical idea, and if in the future, if we survive all these rocks falling in,
that's right,
we can harness a special kind of energy. It's known as negative energy. If we could harness that, we could actually bend space and time ourselves and build a wormhole between 2 points in space.
Oh, it'd just be amazing.
Which would mean that, if you had a wormhole entrance here on Earth and the other one on Mars, that you could just step through and you would be on Mars.
And how quickly would you travel between the 2 points?
Instantaneously. I mean, it's as long as the tunnel. So you can make the tunnel as long or as short as you want. The more you bend space and time, the shorter the distance along the tunnel has to be.
Yes. God, it's just no wonder you became an astrophysicist, mate. It's just the coolest thing in the world, isn't it?
It is good stuff, yeah.
So we spoke a lot about black holes when we were up in Sydney, and how cool and how bloody dangerous those things are. What about white holes? Not many people know about that sort of stuff.
Well, so white holes again are. We have the mathematics. So when you work through the mathematics of black holes, one of the things that comes out is that you can also have this thing called a white hole, which ejects matter rather than sucking matter in like a black hole. The reason why there's less interest at some level is that we don't seem to see any white holes in the universe. So we see evidence of black holes. We see things that appear to be sucking matter in, but we don't really see places where matter is coming out in the way that you'd expect a white hole to work. So again, it's thought that maybe they're just a bit of a theoretical curiosity. They're allowed by the equations, but we just haven't had any mechanism in the universe to create any.
Yeah.
That doesn't mean that in the future that we won't have, again, I said if we can bend space and time the right way, that we could create our own white holes. But at the moment, it's theoretical curiosity.
Yeah, okay, that's really interesting. So black holes, you touched on it before, the only reason we have evidence, well, I mean, I guess we know that they're there, but the only reason we kind of know they're there is because of the things that occur around them. So you can see matter and things being pulled into it, but you don't actually see any evidence for things being pushed around a single point in space. Is that right for white holes?
That's effectively, yeah. We don't see a place where there's loads of matter gushing out. I mean, some people have made some suggestions, but so there are very energetic places in the universe where you do create jets of matter, but there are other ways of making those jets that just involve electric fields and magnetic fields. You don't need to invoke a white hole for those places.
Yeah. Yep.
People are still trying to find the signatures.
Okay, and I guess it's harder as well because the whole universe is expanding anyway, so it'd be hard to find a little expansion within an expansion.
That's right. But people look. That's the key thing, is that that's what astronomers do. They look for what they understand, and they also try and find the things they don't. So because those are always the interesting things.
Yes. Now, Bill and I both love the movie Interstellar. I can't remember when we touched on this before, but Bill wanted to go over the actual physics of the movie itself. Can we talk about the biggest one that people love is those huge waves? Have you seen the movie? Correct?
I have seen the movie, yeah. Cool. I quite liked it. I thought it was a bit drawn out at the end.
Yeah.
But it was a good movie.
Were you really excited? Like, did you have your popcorn and your Coke ready before you were going in? And
I can't remember. I watch the movie so infrequently these days. I did go to the cinema to see Interstellar because it was on the big screen.
Of course, yeah.
So G-Man, I want to ask about the actual logistics of deep intergalactic space travel. Uh-huh. So for us, we can travel around our solar system, but realistically, how far into the future, what do we need to do to be able to actually get to? And I touched on this with Seth Shostak in one of our other interviews from the SETI Institute about what the difficulties and where they lie in actually getting into the Andromeda galaxy. What's the other next closest galaxy?
I don't know. What's the next closest one after Andromeda?
There's the Triangulum galaxy, which is next door to Andromeda.
Yep,
that's right. We have quite a few dwarf galaxies, little galaxies scattered in between as well.
That's right.
So obviously, if we were able to create wormholes, then that fixes all of our problems. But like intergalactic travel to that extent, what do we actually have to do to make that a reality? Say the movie Interstellar was possible. Is that actually close to being physically possible? The theory of what went on in Interstellar, or is it just too far off? There's too many light years away. What's your thoughts on?
Okay, so at some level, when it comes to space travel, right, we are still cavemen.
Yeah.
Right. What we are doing is that we're using chemical rockets to get into space. They require a huge amount of fuel because they're actually quite inefficient. And that becomes a very limiting factor because, as you mentioned, the distances are immense, right? For light to get from here to the nearest star, which is Alpha Centauri, it takes 4 years for light, traveling at 300,000 kilometers per second.
Yep.
Rockets can get up to a few tens or possibly 100 kilometers per second if you really try, which means that if you want to get to the next star, let alone the next galaxy, you're talking thousands and thousands of years.
Yep.
Okay, standard rockets just cannot get to the speeds required to make even getting to the nearest star possible. So we need a revolution in technology. We need new ways of propelling spacecraft.
Right.
And there are people working on it, but of course it's similar to the searching for asteroids. It's a small number of people who often struggle to get funding.
Yeah.
Sucks.
Maybe we could sponsor. Maybe we could do some sort of Adventure Radio fundraiser.
Let's do it.
Yeah.
Me,
we'll
you,
get
and
a
G-Man.
Kickstarter. We'll get a Kickstarter going for the Adventure Radio listeners.
Makes me so annoyed.
It does make me annoyed too.
Well, look, there's people who said that the next step in space is for somebody to realize that asteroids have lots of rare earth metals on them, right? So the metals you need for your phone to work. And we're running out of those on Earth.
Well, it's funny that you say that, G-Man, because I got a guy called Bill Stone. He's lined up to be on the podcast in a month or so, and I got onto him through a TED Talk, and his TED Talk was about we should be mooning the mine. We should be mooning these asteroids to set up basically petrol stations in space for all our rocketry.
Did you say mooning the mine?
Mooning the mine. Did I say mooning the mine?
Yes.
Yeah, well, that's what I meant. He's pulling his pants down, showing his bum to all the miners. But so you think that's the next step? How will that work then?
Well, the next step will be when somebody realizes they can make money out of it.
Yeah, good point.
Somebody realizes they make money out of it, then they put the effort in to do it, right? So we need We need somebody to start work out there and say, look, I mean, there's masses of rare metals and everything scattered through the solar system. It's just hard work to get them.
And hard work to get them back, right?
It's going to take a lot of work, and it's going to be very dangerous, right? Because it's not a very safe environment out there.
No.
But at some point, we are going to run out of stuff on Earth. And I mean, we already know that we are running short of gases like helium, etc. We're going to have to get off the surface at some point. And once we do that, then hopefully that will be the steps of going further and further.
Right.
Yeah. But we definitely need changes in technology. We need new kinds of spacecraft propulsion that are highly efficient.
So what types of new technologies are they working on? I mean, I've heard of a big sail, the big solar sail that creates drive from the sun.
Yes.
That's something that I've read about. Not that I know too much about it, but what are the leading technologies that people are actually putting time and effort into, albeit small funding and small amounts of time they can put in? What are they working on?
Well, the solar sail one is an interesting one because the people are talking about an idea of having a sail, and a relatively small sail, and actually projecting a laser at it to get it to the nearest star. And I think with doing that, having a very light sail and putting a laser on it for 50 years or 30 years will get us across that distance, because the thing will just keep accelerating and it won't have to carry its own fuel.
Right.
Because that's the thing. Sorry to cut you off there, Geraint, but that's the thing about rocket fuel, isn't it? That there's this huge, not a paradox, but almost annoyance with it, that the faster, because we want to make it go faster, obviously the more rocket fuel it needs, but then the more rocket fuel it needs,
the more mass we have.
The more mass it has, so the slower it's going to go.
Absolutely. So there are ideas where you either have highly, highly, highly efficient engines, which basically would use combined matter with antimatter, and that produces radiation, which you shoot at the back, and that makes you go faster. Or you actually pick up fuel as you go, in that you could, I mean, there's lots of very diffuse gas spread through space, lots of hydrogen gas out there. And if you have a big enough scoop, then you can basically scoop up the fuel and then use that to power your rocket.
Huh.
That's cool.
That's interesting.
I'm actually sitting here, I'm looking across to my shelf, because I just had a student finish work with me, and he brought back a book called the Starflight Handbook, which is now 20 years old, this book is, and I've had it for a long time. And these ideas are still being worked on, and people are plodding their way through them.
Yeah.
But again, as I said, we're really going to need a serious investment before we can really get out there.
Yeah.
Right. With the, like, say we do have a solar sail, is what's the chances that we can actually put a human on such a device? And is the next step for us, as in exploration into other galaxies, is it just robotics? And like, can we send photo and video back from other galaxies? Like, is that our best bet to see what's out there, or?
Well, as I said, other galaxies are probably a long way down the line, but other stars, yes, we can send messages back. I actually think that robots are going to be the way for a long time, because as soon as you want to do something with a person, then there are a whole range of issues that you have to worry about, i.e. keeping them alive.
100%.
Which with a robot is much, you can package up a lot of stuff in an electronics box and send it out there, and it'll be much cheaper than trying to send a person. So I think robots will be the way ahead, and then people will possibly follow down the line when our technology gets good enough.
Makes sense. Yep.
Yeah.
Hey, just wanted to quickly touch back on it. I know I mentioned it before, but just with Interstellar, I was going to ask you about the huge waves on that planet, and I wanted to sort of touch on time dilation and then obviously general relativity from that. But can you sort of in layman's terms explain why they went through so many Earth years on that planet, and also too why the waves were so big?
Okay, so
Why don't you pick one question?
Yeah,
I do that all the time.
Yeah,
I ask 6 questions in one sentence.
Tell me who you are? Tell me who you're into. Yeah, I know that there sort of two different things there, but great. But yeah, pick one. We'll go into it.
Let's start with time dilation.
Let's do it.
So again, we go back 100 years and we look at Einstein's picture of gravity and this notion that space and time are sort of rubbery things. Okay, you can bend them, you can stretch them, you can squeeze them. What he found from his mathematics is that means that the rate at which a clock ticks depends upon how strong the gravitational field is that clock is sitting in. So if you imagine I was in deep space and I have two clocks and I keep one in space and I put the other on the surface of the Earth and leave it there and bring it back up and compare the two clocks back out in space, the one that would have been on the Earth would have ticked more slowly because it was in a stronger gravitational field.
Yep.
Okay. So this was the notion in Interstellar, is that the planet they were on was in the strong gravitational pull of this black hole.
Yep.
And the gravitational pull was so strong that the relative clock rate, it was ticking so slowly for the people on the planet that when they went back out and compared the clocks, a lot more time had passed outside than inside.
Yes, exactly. Yep.
Yeah.
So the stronger the gravitational pull, the slower
Time
your
moves
time
around
is.
That's right. Now, you might think, oh, well, that's all to do with interstellar and black holes, but your mobile phone has to take account of this when it uses GPS.
Yeah.
Because the clocks on the satellites in the GPS system are ticking at a different rate to the clock on the surface of the Earth. So if you want the clocks to stay in sync and know where you are on the surface of the Earth, you better take into account this difference in clock rates.
Now, I wanted to, I use this analogy when I try to explain it because I'm obviously a professor of astrophysics. And am I right in saying this? If I was to get two twins and I put one twin at the top of the Great Pyramid of Giza, so something with, quite a big mass relative to us, and he stayed there for his whole life, and then I put the other twin and I put him near like a little book. Let's just say we could do that. He was just holding a book. All else relative, would the twin standing on the top of Giza after 50 years or so be a fraction of time younger than the other one?
Yes.
Yes. Right. Yes.
Like tiny, tiny, tiny amount.
Yes. Yes.
Right?
Yeah.
These things only become really noticeable if you're near a massive object like a black hole, or if you're trying to do something very sensitive, i.e. your GPS measurements, where you really worry about the difference in clock rates. But yes, there would be tiny difference in their age.
Cool. And also, too, if you're traveling closer to the speed of light, your clock is moving at a slightly less time frequency than someone on Earth.
That's right. So that's
cool.
It's known as the twin paradox, and that if you send a twin out into space and they come back, the one that remained on Earth will be much older than the twin that sped off at high speed and then came back.
Yes,
that's actually an argument that I've had so many times in my gym and around the place. Is because there's a Russian cosmonaut who holds the world record for longest amount of time traveled into the future. Am I right?
So he is the guy. He was on Mir, etc. I think he was, and it was like 600 days in space.
Whoa.
So just to confirm, just to validate my thoughts again. So time travel into the future has happened.
Well, you're traveling into the future right now. One second.
Don't get philosophical on us, G-Man.
So
I can edit this out, G-Man. Careful what you say. You got to agree with me.
Yeah.
Yes, effectively. I mean, time travel into the future. If people's clock rates are ticking differently, well, one person will have spent more time getting to a particular point than other people. Right?
So basically, but if that cosmonaut, sorry to cut you off, if that cosmonaut is on Earth, so everyone's clock is ticking at the same time, then he goes into space and our clocks tick faster and his clocks tick slower in space, then when he returns, effectively he's gone into the future by a split second.
Absolutely. So,
yes. Yeah, he's on. Yeah.
Come on. Continue on.
As I said, I mean, you could play the same game if you were near a black hole. You could come down and hover near a black hole and come back out again, and you will be in the future.
Much harder to play that game.
And the closer you get to the black hole, the more into the future you go. So, as we saw in Interstellar, there was decades, but it could be hundreds of years or thousands of years or millions of years into the future.
Right.
I guess the only annoying thing with that is that, you've got a Hollywood idea of going into the future, but you're what we're saying here, it's going into the future relative to someone else. And it's kind of shitty because
relative
obviously
to yourself, because when you left, when you started that travel, you're at point A, and then you're coming back at point C.
Yeah, no, I know, but it's not a thing of like, oh yeah, I went to the future and I saw what the world was like 1,000 years from now. You know what I mean?
Well, if you went fast enough for long enough,
that was a poor example. Yeah. It's like it's not going to the future and. It's not. I'm not talking about. Yeah, it's not cool. It's shit. It's Back to the Future. It's not Back to the Future.
It's shit.
It's not shit.
You're a child.
But you know what I'm saying, G man. Get around me, mate. Get around me. I need this.
Yeah. Look, if they'd stayed on the planet for longer, then when they got off, maybe 1,000 years would have passed on Earth, and they would have looked very, very different, right?
Yes. Yep. Hey, let's talk about aliens. Are we alone?
Are we alone?
Yes.
That's an easy one to answer because nobody knows, right? Because it's a complicated question because at some level we still haven't figured out how life started on Earth. There's various ideas how the first chemical processes give rise to basically creatures and then human beings. And we don't really know if the details of that could be replicated through the universe, so we'd have life similar to ours, or if there are other processes that would give rise to life. My own thoughts are that life is probably common in the universe, but most of it is similar to pond scum rather than people. Right? So, the fact is that Earth spent an awfully long time with just having bacteria on the surface, and then more complicated life appeared. And I think that in the universe, most life will be that sort of bacterial, pond scummy life. Well, so it's impossible.
What do you think about the thoughts that maybe the universe has already had intelligent life and now that's become extinct?
Yeah, so there's lots of discussion about this in that the universe is old enough that they could have had complex life sometime in the past and it's gone extinct. If that is the case, then it should be a lesson to us, right? That, even because we're here, we feel, we're alive, that it's not guaranteed that we will be here into the distant future. But again, people don't really know. There are lots of ideas that there could have been life out there and it's gone extinct, or there is life out there and it doesn't want to reveal itself to us. There's this sort of zoo hypothesis that really we're being studied like some sort of creatures in a zoo. Or that we haven't reached the technological level to become a citizen of the galaxy. So there's lots and lots of suggestions. What we are lacking in is any strong evidence, right? So people are looking for signals from intelligent life in the universe. And as you said, you went to the SETI Institute.
Yeah.
And of course, the SETI Institute doesn't receive government funding, right? It's privately funded.
Yeah.
So that's another area where research funding is hard to come by.
For sure. And the thing that Seth was discussing when we had the SETI podcast was the fact that even if civilization is far advanced enough to be able to send out signals that we can pick up, we've only for the last 20, 30 years been able to, or however long, been able to really, really put the feelers out there to pick up these signals. And then the other thing is there's only a certain window of time until all civilizations are probably going to become extinct. So you've got a little window. You've got because think of how much time there's been life on Earth, and up until just now, we're not sending. Or up until relatively a blink of an eye ago, we're not sending out any signals. You wouldn't think that the dinosaurs were sending out any radio waves. So is that the biggest problem with actually finding if life is on out there in the universe more than life just on Earth? Because we can't actually have no way of really finding it.
All of those kind of things combine in that, as you said, we don't know how long a civilization lasts for that can transmit signals. Those signals get weaker as the distances get larger. We've only really started scanning the sky. So it all compounds to the fact that the fact we haven't seen anything yet doesn't mean they're not there. There's still an awful lot more searching we have to do.
Hey, Geraint, you just said something that really interested me. You said signals get weaker as the distances get larger. Mm-hmm. Do radio waves travel at the speed of light?
Yes.
So wouldn't that always be a consistent pace?
So the speed is the same, but the signal spreads out. If you imagine you've got a source that emits radio waves, as those radio waves go out, they spread out over a larger and larger area. And so the strength, the strength goes up. It's the same way as that, you take a light bulb and you hold it next to your eye and it's really bright, but you hold it across an oval from you and it looks a lot fainter.
Yes.
It's larger. It's exactly the same with radio waves.
Touche. Yeah, that's Bill and I, because we're kind of losery. We were having this chat this morning actually.
Losery.
And that's slightly offensive to you because you dedicated your whole life on this.
Exactly. That's what I was just about to
Sorry,
say.
Geraint. I love it. I love what you do. We're having this chat about, when we started, it was the early 1940s that we sent off the first radio wave signal, I believe. We were having this chat about, it's been, 70 or so years and, no one sort of contacted us. Why is that? It's, all this sort of thing. We were sort of thinking, would radio waves for a super advanced civilization be their form of communication? I mean, there's every possibility that they've developed some higher form of communication and they wouldn't even be able to read radio waves. And the analogy I made was, some sort of distant planet like banging a rock and hoping for the best. Can you shed some light on that?
Yeah, well, so actually the first signals that were strong enough to be really sent off into space were from the 1936 Olympics.
Oh, wow.
And so the first messages that have gone out there probably got Adolf Hitler handing out gold medals. Exactly. Right. Look, radio waves are good because they can travel and they don't interact much with the stuff around them. So if you send out light, there's lots of stuff that light can get absorbed by. So radio waves cut through an awful lot of the stuff in the universe. You're right, though, that even if you receive radio waves, how you would decipher them, right? I mean, people have come up with smart methods of how you encode messages into radio waves, etc., that your radio or your television can interpret. But if an alien receives that, then, what are they going to do with it? And then you're completely right as well that they may have moved on to a completely different set of communication. If they've got wormholes, they might just open a wormhole and hand a letter through, right?
Yeah.
100%. There's different ways of communication.
Yeah.
I would imagine. Like you think of the butterfly effect. You think of everything that's happened in humanity and mankind and everything that we see today. If 1,000 years ago somebody used A rather than B, then everything would be totally different right now.
Yeah, exactly.
I believe. So I think it's folly to even think and assume that everything works the way that we work. But this is another thing that Seth had said. Seth said that he believes that that whenever we do come in contact with radio waves from a distant planet or another solar system, whatever, it's going to be artificial intelligence. He said most likely because we've gotten to the point now where only 1936, like you said, was the first time we could send out radio waves, and then in maybe another 50 years we could have artificial intelligence is the highest intelligence on the planet. Then that might be running the show. This is obviously not a conspiracy theory, but a train of thought. But that goes to say that everything works the way that it works here. It was such a funny. He was great to talk to, Seth, but it's very closed-minded. I think humans are very closed-minded to think that everything revolves, everything works, everything's built up the same way that we've built it up.
Definitely.
I very much agree that in reality, scientists have to think of the things that they haven't thought of. That's the idea, is that you have to say, well, what else could happen?
Yep.
I think one of the other mistakes humans have is that we always assume that what we've got now is the peak of everything.
Yeah.
Right? And even in my lifetime, I've seen things change a lot. And I'm trying to imagine, instead of decades, what's going to happen over centuries and then millennia, that it could be very, very different. And as you said, maybe it'll be AI in some sort of biological jelly that we've invented rather than it being AI on a computer as we imagine.
For sure.
It could be something that nobody has thought of it. I hope it is. I would hate to think that all we're going to do is just make our phones better than they are today.
Yeah.
I would want some really different technology to appear.
I think that there's going to be evolution. I think in thousands and thousands and thousands of years, if humans are still a species, I think there's nothing to say, and this is me, a guy that's got no science background, but I think that there's nothing to say that we couldn't be speaking using telekinesis to speak to each other. Because, put it this way, thousands and thousands, 100,000 years ago, we evolved from something that didn't have eyes. So how are we to know what looking at things was like? How are we to use that sense? We evolved from something that didn't have a nose. How are we to know that smelling things smelled of stuff? You know, I don't understand why. Yeah, this is a whole nother tangent. I don't even know what.
That tangent's really interesting. The thing you just said, Bilbo, about not having eyes is amazing, and it was just the bacteria closer to the surface of the water that was more sensitive to light, and obviously more heated up it died. So the bacteria figured out that by swimming down further, closer away from the sun, was able to survive. Then they were able to be sensitive to light, and then that progressed into a pupil and things like that. You're spot on. I imagine how we are going to evolve, let alone the technology we're going to create in millions of years. It's going to be insane.
What are your thoughts on all of that, G-Man?
Well, I completely agree with you. The key thing, though, is if you're going to transmit information from A to B, you need some method of transmitting it. Mm-hmm. Okay, and we could do. It's bizarre. You could do telekinesis at some level. Just imagine that we evolved a light on our forehead that flashed, and then you have somebody across the room who uses their eyes to see that flash. That's effectively what telekinesis is.
Yep.
Yeah.
And we don't think of it that way, but that's what we're doing. We're transmitting information from one point to another. So you just need a method of having a transmitter attached to your head and a receiver on somebody else's head and something to go between them, and you've got telekinesis.
Well, what about a telekinesis, or instead of having something on your head that goes to somebody else's eyes, how about something in your hand that goes to somebody else's hand across the world to tell them your thoughts? Are we already basically in a state of telekinesis by using Facebook Messenger on our iPhone?
Absolutely. And we forget how easy it is for us to transmit messages to the other side of the world.
Exactly. It's just something
Yeah.
Yep, totally.
This technology we use now, which I send jokes to my brother in the UK, right? I mean, it was unthinkable even 40, 50 years ago.
It was magic.
Well, what we're doing now, I'm speaking to you live right now in Melbourne, and you're in Sydney.
Yes.
It's insane. It is totally insane. Hey, what jokes were you sending?
Best keep those between myself and my brother.
fair. This is an R-rated podcast.
Yeah.
But hey, I think why don't we? Should we start? Did we get 6 from 6 going?
We didn't. Did we ask you 6 from 6?
Didn't.
No, we didn't, did we?
Didn't.
Hey, I wanted to ask you one more thing, Geraint, before we get 6 from 6 moving on. We've spoken a lot about the universe and stuff that we all sort of love. I'd love to know more about you yourself. Anything you're working on the next 10 years for Geraint Lewis?
Okay, so what am I working on at the moment? That's a good question. I'm actually teaching at the moment, so I've got to teach electromagnetism this afternoon. Research-wise, I'm looking at the Andromeda Galaxy.
Nice.
And what we've found is that around Andromeda, we found basically the debris from smaller galaxies that have gotten too close and have been ripped apart. So I'm working on measuring how much debris is out there and what that means for the evolution of the Andromeda Galaxy, because that galaxy grows by eating smaller galaxies.
Really?
Yeah.
We discussed this in the first.
We did
show,
too.
mate.
Yeah, that's right. I completely forgot about that.
Man, he has a terrible memory.
I do have a terrible memory.
The bloke sitting next to me.
So, Steve...
the other thing that I'm working on at the moment is I'm looking at what's known as non-standard cosmological models. So this basically means trying to understand how dark matter and dark energy could potentially interact and what that means for the universe. So it's a very big topic, and we're just trying to sort of carve a niche in there at the moment by looking at the way the universe has evolved with non-standard cosmological models.
All right.
Wow, that sounds really, really complex.
Yeah. Sounds above our pay grade. Hey, so So, G-Man, we didn't get to finish off on the first show with 6 from 6. So now, obviously, like we've gotten you back on, we want to finish it the way we normally do, and that is 3 questions from myself, 3 questions from Tommy. They're reasonably rapid fire. Are you ready for them?
I guess so.
That's a no.
You have to be.
That's a no. But, okay, so my questions are travel related. Are you a well-travelled man?
Yes.
Good. This will be perfect then. So,
do we need more than that?
No, that's not one of the questions.
I travel. I travel a lot for work, and so I've been to lots of countries for work-related stuff, and I enjoy traveling quite a bit.
Okay, cool. So, first question then is what's your favourite travel destination on the planet? Can be big, small, little country, little towns, country, continent, anywhere.
I'm going to be rather parochial and just say that I really enjoy going back to Wales.
Cool.
Which is where I grew up. I grew up there, and I somehow missed the fact that the countryside was beautiful and it has loads of castles and things. Mm-hmm. And now when I go back there, I'm completely stunned by how lovely it is.
Awesome. Good stuff. So next question is the dream destination for you on your bucket list. Same thing. Can be small, big, large, continent, other planet, galaxy.
If my bucket list is to keep traveling, I don't have... I'll say one place that I want to go to I haven't been to yet is Vietnam. That's on the list. My wife and I have spoken about it quite a lot. When I explained it to the kids when they were younger, we were thinking about going to Vietnam. They told their friends we were going to Afghanistan. So we had to correct them with regards to that.
Yep.
But yeah, so I want to do Southeast Asia. I've only been to Singapore in Southeast Asia.
All right, cool. Sounds good. So how many countries have you been to, do you know?
No, lots.
Cool. That's good. That's what we like to hear.
In the many tens, at least.
Oh,
yep.
Cool. That's cool.
All right, and last question. If you had, did I change my last question in the last show?
Potentially.
Was it 3 books? I changed it 3 books.
Oh, you did do it. No, 3 things on an island.
No, that's a normal question.
Oh, yeah, that's a normal question.
All right. So the last question is, if you're on a desert island and you have 3 things to keep you sane, what are those things? You've got food and water and companionship and so forth, but 3 things to keep you sane, what are they?
3 things to keep me sane. Am I allowed a laptop?
Absolutely you are.
Okay, so the things that keep me sane at the moment are, well, I'd say 3 things, but they're essentially done on the laptop. Writing. I do a lot of writing, and so I enjoy writing. I've got a book coming out in September, actually, and I will continue writing.
What's it on?
It's called A Fortunate Universe, and it's about the fact that the conditions of physics in the universe seem to be tuned for the appearance of complex life.
Oh, that sounds amazing.
Yeah, and if the universe had been born slightly different, it would probably be dead and sterile. So it's about the mystery of why there's life in the universe at all.
Oh, that's awesome.
Sounds good.
I also enjoy doing ray tracing, which is basically making photorealistic images.
Right.
And so I've got a piece of software I use that I just play around with more than anything.
Huh, interesting.
And the other thing, am I allowed a big bookshelf? Because there's a lot.
You can have a Kindle.
I can have a Kindle. Oh,
with a solar Kindle.
Okay, solar Kindle. I'm a big fan of classic science fiction books, H.G. Wells, and the 1800s and early 1900s sort of science fiction.
Yep.
So I'd happily read those books.
Awesome.
Sensational.
Good stuff.
Let's flip it over. Let's move on to my 3 from 3, my friend. Did you have a role model growing up? Biggest role model as a kid, or maybe one now? I've got a hunch of who I think it may be, but I won't tell you until you say your answer.
Role model, that's a tricky one. I don't really remember. One thing I did learn when I was quite young is that I share a birthday with Einstein.
Oh, wow.
So I knew about Einstein when I was quite young.
Yeah.
But I don't think I had a role model I can really identify. I think I wanted to be Doctor Who when I was a kid.
Oh, yeah.
Yeah, but...
Do you still watch Doctor Who now?
Yeah, I do.
It's good.
My youngest son still watches it. My
Yep.
eldest one has outgrown it, but my youngest one still watches it.
I'm the same. I've got 4 kids. No, I don't have kids. Hey, I thought you were going to say Carl Sagan.
You said no. Yeah, look, I knew of Carl Sagan, and I did see the Cosmos show when it was shown on TV. But I think I was just at the wrong age. I was a little bit too young when it came out, and I read the book then when I got to university. So I didn't have him as a role model as growing up.
Sure.
I wasn't much of a science person when I was growing up, to tell you the truth.
Yeah, I remember you saying
What
that
were you
when we spoke last.
I don't know. I sort of fell into science at some level, and I thought I was going to end up working in the coal mine, which is where my father was working. But luckily, they all closed down.
Yeah, that's right. Hey,
Luckily for all the people that lost their jobs and all the people that went bankrupt in that.
My dad.
luckily that's not me. Hey, second question. What do you, maybe something a little bit different to astrophysics, what do you like to do when you've got some downtime, apart from study and spend time with your family?
I used to run a lot, but my knees are getting a bit knackered, and so I actually cycle a lot now.
Oh, no.
That's right. I like to. This is going to sound not that good. I like to cycle while listening to podcasts.
Adventure Radio.
Actually, I'm trying to understand the world of economics, so I listen to economics podcasts.
All right.
For
well,
economics?
Yeah, definitely Freakonomics. And
Freakonomics is
also
good.
some of the cool ones from the UK. There's Wake Up to Money and that kind of thing. So when I live in Sydney, I'm at the top of Lane Cove National Park, and I can get down into the bush, and so I go cycling down there. When it's dry, and I can go between many of the suburbs. So that's what I like to do if I'm not actually working.
There's a great podcast, Adventure something out there.
I think somebody mentioned it before.
Yeah.
I think I mentioned it before.
Yeah, you mentioned it before. Geraint, do you know?
Radio
I
something.
think I know the one you mean. I like to see if I've got that on my podcast list.
Yeah.
I'm sure you will.
You'll know.
You will, of course.
You'll know. Hey, and last one, my friend. If there were 3 people you could invite to dinner, dead or alive, who would they be and why? And your family is more than welcome to join as well.
Oh my goodness! Sorry. Do you know Alan Partridge?
I do know Alan Partridge.
Is he a comedian?
He's a comedian.
Yeah.
And he does a fake radio show. And he was asked this question about who he would invite to dinner.
All right.
And his response was Jesus, Margaret Thatcher, Dennis Thatcher, who's Margaret Thatcher's husband, and then it was the Thatcher children. So that was it. Who would I have? I would like to meet Einstein, H.G. Wells, and Fred Hoyle.
Fred Hoyle. Who was Fred Hoyle?
He was a cosmologist in Britain in the 1950s and 60s. He's the one that worked out how stars burn and make heavier elements.
Wow.
And he is also famous for being the person who invented the term Big Bang.
Oh, okay.
Right.
Yep.
Which he invented as a disparaging remark because he didn't actually believe in the...
Oh, that's right.
I remember that
I
story.
remember that guy, yeah.
I actually have met him because he was, when I was a PhD student, he was the previous head of the institute that I was in. And he always struck me as being somebody who was interesting because he always thought left field, and he wasn't afraid to consider a wacky idea. And some of them turned out to be completely wacky, and others turned out to be quite successful. So yeah, those 3, I guess.
Hey, I'm just sort of thinking to myself here. Astrophysics is a huge passion of myself and Bill's. It'd be so cool if we could get like you, Neil deGrasse Tyson, Brian Cox, like Richard Dawkins, and all just have this huge orgy. All just have this massive...
Circle jerk.
Yeah. All just have this huge Skype. It'd be amazing. It'd be so cool.
Sorry,
We've lost it a little bit here. Right. Hey, last thing...
Richard Dawkins an astrophysicist or an atheist?
Richard Dawkins is not an astrophysicist.
No.
He's a biologist.
He's a biologist. That's right. He's a biologist, yeah. They got out of hand there.
Brian Cox isn't an astrophysicist either. He's a particle physicist. But we won't mention that.
Oh, that's right. Yeah. So thanks for bringing me up on that. Hey, last one, G-Man. If there's one way that people can find you on social media or anything you want to plug, now's the time to do it. Do you want Mention some names, mention some things.
Okay, so I'm on Twitter. My Twitter handle is @cosmic_horizons. And also we have a Twitter account for our book, A Fortunate Universe, where we'll be answering any astrophysical questions that people have. And we also have a Facebook page, but I don't know how Facebook works. So
Fair enough.
if you search at Facebook for A Fortunate Universe, you'll find our page.
Cool.
And of course, I'd love to recommend people go out and buy my book when it becomes available.
Is it on pre-order? Is it pre-order at the moment, or when will it be available?
On pre-order on Amazon. So
Awesome. I'll definitely buy it.
A Fortunate Universe.
A Fortunate Universe.
All right. Awesome. Well, thank you so much for a round 2. I think we covered off on a lot of really good stuff there, and
Loved it. Absolutely loved it.
And I think we might try and come up with some more questions and hit you again when we're in Sydney in 12 months' time or something, G-Man.
Definitely.
Absolutely. Sounds good.
Hey,
All right.
I'm going to speak to you personally, Geraint, because I'm going to buy a telescope really soon. I want to know the best ones out there, so we'll get that organised.
Yes, I can point you in the right direction for that. But often, a really good pair of binoculars will outdo a basic telescope.
Really?
So,
Also really good for other things as well.
Just spying on the neighbours. And oh, cool. Alrighty. Thanks, G-Man. Absolute pleasure. We'll talk to you soon.
Thank you very much. See
Thanks,
you guys.
brother. Bye.
Bye.
Alrighty, guys. That was the final part of Geraint Lewis. We towards the end of the show, we were so bloody excited there. We're definitely going to get him back on when we hang out with him up in Sydney.
Do they think they like my circle jerk joke?
I don't actually really know what he... That got so sexual towards the end. I don't know what a circle jerk is. That didn't sound Welsh at all, did it?
Terrible accent.
Well. Yeah, no, he's a champion. So we're going to hang out with him. Hey, guys, if you want more of that sort of content, please just let us know. Email myself or Bill. You can find our stuff through Adventure Travel, which is a segue to what I want to say now. If you heard something through the show that you thought was pretty effing rad, you can jump onto our show notes at www.adventuretravel.com. Click the podcast link. Go to the podcast that we're talking about, and it's got all the stuff there, okay? And while you're on there, you can join our mailing list. Bill, do you want to talk about the mailing list?
Yeah, so the mailing list can be found on the website, guys. If you're on our mailing list, you'll get all of our blogs from our bloggers, all of our podcast updates, all of our trip promotions and updates, everything and anything going on with Adventure Travel. And it's all there. So make sure you're on that.
Cool.
And you will never miss a thing.
Guys, don't forget to jump on audibletrial.com/ADVF radio. That's RADIO. You know we love it, guys. We know you love it. Everyone get around it. Alrighty, until next time, team. Goodbye.
Peace.
Goodbye.
Discovery Roger, go for deploy.